Hey everybody, it's Ripley back again. Hey, I'm going to work on this small tablet. For whatever reason, I upgraded my computer to Windows 7, and when I open this tablet all the way up, Windows and Camtasia and my tablet want to fight with each other. So, excuse me, I'm going to work on this. Hopefully there aren't any dirty words or anything over here I got to worry about. I'm guessing not. All right, now watch this. I know that 1/2 plus 1/3 equals 5/6. Right? Partial fraction decomposition reverses this process. I'm going to start with my fraction, and I'm going to figure out which two fractions add to make that fraction, because every fraction can be expressed as the sum of two fractions as long as the numbers are rational. Excuse me. So I can think of 5/6 as 5 over 2 times 3, and then I'm going to pull this thing apart and turn it into the half and the third, and in this case we know that this 1 ends up being in here and this 1 ends up being in here. But we're going to do this algebraically. We're going to do it with rational functions. Now this is one of those annoying topics where you're not really going to see the import in this until you have done calculus. We're going to use this in calculus over and over again. So this is just an introductory course in this because I want you to be comfortable. I'm also going to show you two techniques that are pretty cool to be able to figure these types of things out. So watch this. Here we go. I'm going to take this expression. Let's go x squared minus x minus 6. And I am going to turn it into the sum of two fractions. Okay? Now, the process is always the same in the beginning. The first thing that you always want to do, in algebra, when in doubt, factor, right? So the first thing I'm going to do is I'm going to factor this thing into x minus 3 and x plus 2. Now, I have no idea what the numerators of this thing are going to be yet. So I'm going to stick an x minus 3 here and an x plus 2 here, and then I'm just going to stick a constant. How about capital A? Capital B. I know in the past we've used capitals to denote matrices, but we're not going to do that this time. Now, here we go. I'm going to show you both ways in terms of how to solve this. And I think you'll like one over the other. It's kind of a clever way. But I do want you to see them both. All right, the first thing that I'm going to do is, and this may seem a little counterintuitive at first, is I'm going to re-multiply the right side so that I get the exact same denominator as the left-hand side. So I'm going to get an x minus 3 times x plus 2 in the denominator. Now, do you notice what I get is a times x plus 2 plus b times x minus 3. Now, you may say, well, why did you do that? The reason I did that is because now I can ignore the denominator because I'm only concerned with the numerator. And I already know that x can't be 3 and x can't be negative 2 or all hell breaks loose. So, check this out. I'm going to rewrite this as ax plus 2a plus bx minus 3b equals 1. And then what I'm going to do is I'm going to gather my terms. I'm going to gather my terms by my x's and then by my constants. And what I'll end up with is 1 equals a plus b times x. Now, bear with me for a sec. You'll see why in just a sec. Plus 2a minus 3b. Now, I'm also going to rewrite the left-hand side, and I'm going to rewrite this as 0x plus 1. The reason that I did that is it gives me a ton of information. Since I have an equals sign right here, I know that the left-hand side equals the right-hand side. So whatever's going on the left-hand side has to be going on the right-hand side. In other words, because a plus b is the coefficient of x, and 0 is the coefficient of x on the left-hand side, I can equate those two things. I can say that a plus b equals 0. Similarly, because 2a minus 3b is the constant term on the right-hand side, and 1 is the constant term on the right-hand side, I can equate those. So I know that 2a minus 3b equals 1. Now this is actually pretty simple. Let's change colors just so we know that. Now we're in algebra mode. Oops. So this implies that a equals negative b. So wherever I see an a, stick a negative b. Right? So there's an a. I'm going to stick a negative b. So I get negative 2b minus 3b equals 1. So negative 5b equals 1. So b equals negative 1/5, which implies that a equals 1/5. So what we just said is that 1 over x squared, I guess what we just showed is that 1 over x squared minus x minus 6 can be written as 1/5 over x minus 3 plus negative 1/5 over x plus 2. Now, don't take my word for it. Prove it. Watch what happens. If I cross multiply this, do you agree that the right-hand side will turn into 1/5 x plus 2/5? And then if I cross multiply, as though I'm finding a common denominator, right? I'll show that denominator here in just a sec. Minus 1/5 x plus, that's 2/3, that should be 2/5, excuse me, plus 3/5. And then the whole thing is over x minus 3 times x plus 2. Watch what happens. The 1/5 x and the negative 1/5 x go away. Last I checked, 2/5 plus 3/5 is 5/5. And I end up with 1 over x minus 3 times x plus 2, which is exactly the same as this. So consider this part to be the proof. It's pretty cool, huh? Again, look at what we did. We took, instead of adding two fractions to make one fraction, we took one fraction and turned it into its component fractions, which are then summed together. And this is how we do it. Now, I'm going to do it again. I'm going to show you an easier way. I think you'll like it. So what do I have there? A over x minus 3. Whoops. I have 1 over x minus 3 times x plus 2 equal to a over x minus 3 plus b over x plus 2. Now, instead of doing that whole systems of equations thing, watch what I do here. I'm going to turn this guy into a times x plus 2 plus b, whoops, times x minus 3, the whole thing over x minus 3 times x plus 2. Again, I do that so that I can get rid of the denominators. I can ignore them and just deal with what's going on. Check this out. Watch how easy this is. I'm going to let x equal negative 2. Now you may say, Ripley, that's an awfully arbitrary number. All right? Why are you letting it equal x, or letting it equal negative 2? Oh, do you see why? If x is negative 2, and I plug it in here, watch what happens. This implies that, well, this guy goes away. This is a times 0 plus b times negative 2 minus 3 is equal to 1. That's the left-hand side over here. I turned it into the right-hand side. That's b, not a 3. Right? Got a little lag. Gone. Negative 5b equals 1. Guess what b equals? Negative 1/5. Now, remember, theoretically, we don't have the benefit of hindsight to remember that a is negative b. So what would we do in our next step? We're going to let x equal positive 3. Why? Because it makes this term disappear. So this implies that a times 3 plus 2 plus b times 0 also equals 1. Yeah. So 5a, equals 1, not 0. Man, I'm saying one thing today and something else is coming out. That's 1. My girlfriend would say that happens every day, but anyway. All right, so a equals a fifth, b equals negative a fifth, and look at this. That's the same as our answer right here. A equal to fifth, b equal to negative fifth. That's a lot easier to do, though, isn't it? Now, there's no guarantee that you're never going to have to use systems of equations. However, that's a nice little trick. Okay, now, let me show you one, because this introduces a nice little rule. What if I have, let's go, 2x plus 1 over x squared times x minus 2. Who cares? Same rules apply. There's only one problem. This is a squared term. And the way in which we deal with square terms, and I'm going to let you play with this numerically in class. Why is this true? I want to plant a seed and see if you can figure out why. Hey, it may even show up on an exam as an extra credit question. You never can tell. The problem with these is that think of this as x times itself. So if I wanted to factor this, I suppose I could write this as 2x plus 1 over x times x minus 2. Now, the way in which we deal with squared terms is we rewrite this whole thing, not like this. I wouldn't want to write this as a over x plus b over x plus c over x minus 2. What I am going to do is I'm going to write it as a over x plus b over x squared plus, now we've got a linear term here, and we've got c over x minus 2. All right, now notice this x squared term is factored. That becomes really important. Okay, so bear with me. Let's see if we can get through this thing. Again, finding my common denominator, I'm going to write 2x plus 1 over x squared times x minus 2 is equal to, now let's think about this. The common denominator is this guy. This is just an x, so I need to take a and multiply it times an x and an x minus 2. Everybody see that? Plus b. Common denominator is x squared. b has an x squared under it. I need an x minus 2. So b times x minus 2. And then c has the x minus 2, but it doesn't have the x squared term, so I need to multiply by x squared. So plus c x squared, and this is all over our common denominator. Again, we make the common denominator so we can get rid of it. All right? And now we're just dealing with the top. Now, can you see a nice little number that might work out here? If I let x equal, can you see a number that would make some terms go away? How about 0? Let x equal 0. Doesn't this imply that this term is going away and this term is going away? Ooh, we got to respect that x as well, don't we? So the only thing that I'm left with, because a times x, which is a times 0, disappears. Who cares what else is there? And c times x squared, which is c times 0, disappears. What I'm left with is negative 2b, because that's what comes out of this term, is equal to, well, that's a 0. So 2 times 0 is 0 plus 1. Plus 1, right? So I guess I should put a 0 there if I had to. So b equals negative 1/2. That's pretty cool. What's another one? What else can I let x be that might make our lives simpler? Can you see? How about let x equal 2? Now, this term and this term goes away, don't they? Because they have an x minus 2 in them, which implies, well, let's see, if x is 2, then c has got to be what? What's c got to be? Well, it's got to be, or excuse me, what does this term turn into? 4c equals, now x is 2, so I plug it in on the left. So I get 2 times 2, which is 4, plus 1 is 5. And c equals 5/4. Oh, I'm out of room. I hate it when I do that to myself. Okay, so I got to rewrite this thing.